Sweet. So this talk is about how we took Django, our favorite tool for our backend, our web frameworks, and Unity to create a game. So real quick, I was just introduced, co-founder, head of tech at Yeti, product development firm Yeti. I also organized the San Francisco Django meetup group. Been doing that for a couple years now. Generally full stack developer, kind of started a lot with Python and Django, but I've done Swift, iPhone apps, JavaScript, Angular, React, Java, Android, and then recently added C# when I started to dive into some Unity. As a kid, I love games. I'm sure many people here also felt the same. Growing up, I made games in RPG Maker. I don't know if anyone is familiar with that from a long time ago. I made this like mutant cow, you were like a farmhand game. I don't know. I still got it saved somewhere on a PC. So it was really exciting that we undertook making a game at Yeti. So quickly, to get some context, we want to make a game. We wanted to try out virtual reality. We're an agency, and it was like we want to use Django. How does Django work with Unity? We want to create an API, add some more dynamic functionality, be able to have users in the game. How do we hook that up with Django? So generally, we're going to go through today. We got 45 minutes, so a longer slot. So we got an introduction to virtual reality, talking about our game a little bit just to understand the game mechanics and why we're using an API, how virtual reality in Unity works, some quickly going over the Django APIs, and then how really the meat of this talk and the takeaways is how to consume those APIs in Unity. So really quick, smaller aspect ratio, my slides are going to be all messed up. What's not in this talk, this isn't a Unity 101 talk. We're not going to be talking about how do I build my first game in Unity. There are plenty of tutorials and other things you can go. That would take a really long time in itself. For the APIs, we use Django REST framework. Plenty of other talks and tutorials. I'm not going to be going in depth on how to use DRF. So this is not like a step-by-step walkthrough. Let's cobble together our first game and talk to Django and DRF. That's way too much. I will provide a bunch of resources at the end of this talk, though, where you can go to find those things. What is in this talk? The idea is to be familiar enough and to know right now what you don't know about maybe Unity or virtual reality development so that you could go, you know where to look to get started. And really that you don't make the same mistakes that cost me like many weeks of trying to figure out how to get Unity to talk to Django and just getting familiar with it myself, coming from a predominantly Python and Django background. Also, there's a quiz halfway through the talk, so you are motivated to pay attention. The quiz will be happening either via your laptop, tablet, or phone, so make sure you're ready with that halfway through. All the questions are going to be, and the answers are going to be things I went over. The top 2 people will get a Google Cardboard. I came up with this idea rather recently, so I don't physically have them. I will ship them. I know. They're back. We have a bunch back at the office. I was like, I wish I had this idea earlier. But we will ship them to you wherever you live. International. We'll have to see how much that shipping costs. It's only a piece of cardboard. But so the top 2 people will get some prizes, so you should pay attention. So quickly, I want to talk about basically virtual reality. Show of hands, who would say they're familiar with the different virtual reality headsets and platforms and what's going on? Okay, maybe half. Half the audience says they're familiar. So this is going to be painful. So the brief state of virtual reality, there's a picture missing off to the right. So right now, basically, there's virtual reality headsets that deal with using your smartphone, and there's ones that are likely connecting to your computer. And so going from left to right there, we've got the Vive, the Rift, PlayStation VR, Google Cardboard, and the one off to the screen is the Gear VR. So generally, the PlayStation 1 obviously hooks up to PlayStation. The 2 on the left are currently, you likely have a gaming PC, and you're hooking those headsets up into your PC. The 2 on the right, the Cardboard, is you put your smartphone into it, either iOS or Android. And then the Gear VR, which is off to the right there, is for your Android phone only, currently. So a lot of people have dubbed this year as the year of VR. So mostly all of these headsets shipped. The Rift and Vive started to ship out to all the people that pre-ordered it. The Samsung Gear VR started to get packaged with actual Android phones that were being sold. The New York Times sent out to their subscribers a bunch of Google Cardboards with their subscription, and they also came out with an app that had a bunch of kind of like 360 experiences for you to use in the Cardboard. And PlayStation VR, kind of the last one, is due out at the end of the year. So there's kind of this desktop versus mobile. So some people consider smartphone VR, i.e. the Cardboard or the Gear, basically as like virtual reality light. And it's pretty true. I mean, it's hard for you to use your smartphone and repurpose it by putting it in maybe just a piece of cardboard versus buying a dedicated headset and controllers that you plug into your computer that are taking the full effects of your graphics card that's on the computer, all of the things built into the headset itself. Google Cardboard actually rebranded as Google VR kind of recently, so I might interchangeably call it Google Cardboard or Google VR. Essentially, Google's trying to come out with maybe another controller and their own thing called Google Daydream. And probably Cardboard maybe isn't the greatest name if they want to make that a solid platform that they have marketing behind. So they're trying to rebrand, but when we did this several months ago, it was not Google VR. So you'll see me referring it to Cardboard, Google VR. A big concern with this VR light, hence the pumpkin that's throwing up on the side there, is feeling nauseous and this screen door effect. So if you took your smartphone and you put it up right in front of your face, the resolution isn't good enough. You will see the pixels that are actually on your phone. And so essentially that's called the screen door effect. Some of the dedicated headsets, right, that you plug into your computer have improved like the field of vision and the resolution, and they've tried to come ways to get rid of that screen door effect and make you feel more immersed, so you less of a chance of getting sick while you have it on your head. Probably the other important fact also is that on mobile you have limited inputs. So the Vive and the Rift and PlayStation VR are all going to have actual other handsets or controllers that you are using while playing with it. The Cardboard, for example, has just one interaction point, a button, and the Gear has some buttons and touchpad on the side, so a little bit more than Cardboard. But because for Cardboard, you actually have to hold it up to your head. It's not even strapped on. Your hands are not free to be using other controllers. So those are all concerns when trying to make a game and thinking about your game mechanics. So there's some other applications right now for VR too. Obviously, games was the first one. But people have started to do a lot more around entertainment and media. There's 360 photos and videos. There's a whole bunch of cameras that have come out. There's some interesting things in like education and healthcare, and also travel and real estate. You imagine you could go and explore some house via virtual reality sets, or you could go see where you might be staying somewhere. From one of like the early demos, this screenshot is this Titans of Space, which is a cool demo someone put together for one of the original Oculus development kits, where you basically fly around a bunch of the planets, and it's narrating you through them, telling you about the planet, the size, how far away it is from the sun, etc. So there's a lot of possibilities with education in the VR space as well. So we're going to talk about the game really quick, just so that everyone has an understanding. So disclaimer, this is the first game I've ever really built and launched on an actual platform. Really, it was an experiment to try out virtual reality. We came up with a proof of concept that seemed like, hey, this is pretty fun. Maybe we should build this out further. And then we actually created what we like to call at Yeti an MLP, minimum lovable product, versus minimum viable product, which doesn't mean necessarily that your users are actually going to enjoy using your MVP. So we tried to come up with something that might be fun for someone to download, try out on their phone. And for us as an agency, this was experience with new tech, a bit of a portfolio building thing, and for fun. We have basically like 20% time at Yeti, and it's probably spilled over started in our 20% time as a project and then turned into a real one we wanted to see through onto the App Store. So why do we choose Google Cardboard? Accessibility. It's only $15 for the headset, the piece of cardboard. At the cheapest, there are some more luxurious Google Cardboards you could buy, compared to spending hundreds and hundreds of dollars, right, for the dedicated ones that you would plug into your computer. There's a greater potential audience. Essentially, anyone that owns a smartphone can just get a $15 piece of cardboard and become a virtual reality user. The game we came up with, which I'll talk about, has pretty simple game mechanics and doesn't necessarily need to take the full control of having a bunch of controllers or any kind of room scale VR where you're actually moving around. The idea is you're standstill. And it seemed more approachable as a first-time virtual reality game that we were building. It seemed much easier than maybe tackling all of the different inputs and other things going on with the Rift or the Vive. So the name of the game is Tiny Eye. It's essentially, if you've ever, as a kid, played the game I Spy with My Little Eye, and you said something, and one of your friends picked out something else nearby. You're in this 3D world. You're looking around. It prompts you with 4 objects you need to find. You need to look around, all around you. Essentially, you're in these miniature worlds. The levels were actually made with toys themselves. Because of the camera and their perspective, you look like the size of like a NASCAR, like a little car toy, or you look smaller than a doll, for example. There's a bunch of hidden objects. There is a mode that you can play without a Google Cardboard in it. So you can just basically like look around in space, or you can have it up and actually be using the cardboard. You basically play through the levels, you unlock them. There's different difficulties. Some objects are harder to find than others. So really quick, just so everyone...
That's an excellent.
Oh, there's audio and it's loud.
Over here.
So basically, this is Ellie from our office. This is one of our proof of concepts that we made first. This is not the final version. But the idea is she's like looking at 2 levels right now that we made in our proof of concept. The TV is actually hooked up and streaming what the phone is in the cardboard right now that she's using. So essentially, you pick a level, you go in, it prompts you with the objects that are there. So a lot of our proof of concept stuff was just like, how does this work? How do we get a 360-degree photo mapped to a Google Cardboard app? We had a lot of things that the designers weren't happy about that I had to polish and work on, animations, interactions. But really, so she's just looking around right now in the world, right, and trying to find some of the objects that were specified there. The actual levels themselves, I didn't partake too much in it, but I know the people who did. The office had a lot of fun. They literally took toys and made little worlds. We used this camera on the right here. It's called a Ricoh Theta S. 360 cameras, surprisingly, are not as expensive as you would think. There's people that put together like a GoPro rig where you put like 10 GoPros in a circle, create these large 360 photos, videos. They're starting to come out with smaller and smaller cameras that are cheaper and cheaper. So this camera just basically has 2 lenses on each side that stitches together the photo into 360. So really, we put together these little levels with toys, and then essentially just put the camera in the middle of the level and took a lot of figuring out which objects in the photos are going to be the ones that the user was going to have to find, making sure that things were the right distance away from the camera. Meant our design team got to play around with toys for a week or more. They had a lot of fun. So we had a lot of different themes. Some of them got pretty elaborate. This one on the left is like different landmarks of the world type of one. So that was a lot of fun putting the levels together. We tried a few different types of concepts until we landed on this one called Dino War, which was dinosaurs versus army men. And that was when it clicked that having themed toys and it being in this miniature world was a lot of fun. And so once we got that first one down, then we just started getting kind of sets of toys and setting up these levels. So Tiny Eye kind of little overview of the architecture. The backend, the API is Python 3.4, Django 1.9. We use Django REST framework for the APIs. For Unity, we use Unity 5, which is the latest version. We use C#, not JavaScript. You're able to use both in Unity, and at first I was like, well, out of the two, I guess right now I'm going to pick JavaScript. And I quickly stopped and switched back to C#. There is some concerns about you writing code in JavaScript and it integrating with other plugins or other code that you're using that's using C#, especially like in order of execution. And if you want one that needs to import another one, there seem to be a lot of complexities, and a lot of example code and stuff you're going to find on GitHub and whatnot is all written in C#. So I took the plunge. We use Postgres for the database on the back end. We did deploy it cross-platform through Unity, which means we built it for both iOS and Android and deployed it on both stores. And we use Google Cardboard's Unity SDK. That's essentially the thing that helps make it run on the phone and show you those two different eyes, which I'll talk about more later. So some other services used, and we got to use a lot of other common stuff that we use on most of our other apps. So Fabric, we have some like Twitter integration, but specifically we use their statistics reporting and Crashlytics. So Fabric has an integration with Unity. We use it also on our iPhone apps, for example, our Android apps for error monitoring. Pushwoosh for push notifications. We use a lot of just Unity. Unity has a whole Unity services section, so we use one for in-app purchases that they have. And then we use Sentry for any error reporting on our API on the back end. All right, so quickly talking about just VR in Unity. Unity basically is making a big push to include virtual reality just as part of the platform, trying to have very much a batteries included type approach. Unity is all about cross-platform development. You try to create your game, and it's going to work on many platforms. So right now, it has built-in virtual reality support for Rift, Vive, Gear, PlayStation. Cardboard's basically the only one it doesn't have built-in support for. It's coming soon. Instead, you just have to download SDK from Google that you just put into your Unity project. But it's essentially the same as building your 3D game. The key differences are thinking about the controls and the inputs are quite different than maybe someone using a mouse and a keyboard, for example. And it's really all about thinking about the person with their headset on, and that the camera in your game is really the person's head. And so there's a lot, it's really the key to just thinking about virtual reality game development for me in Unity. So really what we saw is you've got the two different perspectives for each eye. And really it's all about this camera object that you create in Unity, and it has a different camera for both your left and right eye. Virtual reality works by just offsetting what each of those eyes are seeing to give a perception of depth in the virtual reality world. So Google Cardboard comes with this camera object that you just use in Unity. These pre-built objects are called prefabs. So there's this camera prefab that you can just use. And it's also key for if there's things in the UI that need to always appear in front of the user's gaze and where they're looking. So for example, if you want to have some kind of cursor or target or reticle in front of the user, you can apply that to the camera and just make sure it's always X, whatever units of measure you want to say, in front of where the user is looking. So that's kind of key about how to think about virtual reality development and how it differs from regular game development in Unity. The other issues we came across, it seems if we want to port this game to Gear or Vive or Rift, right now it doesn't seem super straightforward to build one game and then have it build for PlayStation, Rift, Vive, Gear, and Cardboard. I think maybe Unity's ultimate goal is to get there. But right now, we definitely looked at how Unity was working, and we picked Cardboard. And so if you were to try to make a game, I think you're going to want to pick one to start with and worry about making it cross-VR platform, if that's a phrase, later. Because the inputs and controls differ greatly. For Cardboard, you can, like I said, deploy to both Android and iPhone. The trick is for Unity, a lot of it, you have to pay for all the different add-ons and plugins. So worth noting, if your end goal is to end up deploying this onto one of the stores, you're going to have to be paying for Unity Pro, and you're going to have to be paying for both the iPhone and the Android add-on if you want to deploy to both. So it's a caveat. You can actually wait to purchase all those things right until you're about to deploy on the App Store. Tip, if that's what you're thinking about. All right, so quiz time. So on your device of choice, go to kahoot.it. This is going to be an interesting exercise. I can't control the volume, so this might be really loud. My apologies. All right. So I've asked you for the game pin. So what we're going to do is top 2 people. I will ship some Google Cardboards to. So not only does it count, there's only 5 questions, you got 20 seconds to answer each question. But points are not only about getting the answer correctly, it's about getting it the quickest. So we're not going to end up with like 20 people all getting all 5 questions right. All right. How are we doing? Anyone need more time? Huh? Yeah. All right. I think we're gonna start. We're still in. Names are still coming. I don't. We. All right, we're starting. No. All right, which headset has the least amount of inputs? So you got to click the right corresponding answer on your device. We didn't even need 20 seconds. People are on top of it. Cardboard, it's only got the one button. Everything else at least has controllers. Even the Samsung Gear has multiple buttons and a touchpad on the side. The one button on Cardboard makes it kind of really difficult to make any complex VR interaction. All right, there's the top 5. Be Slick and Dane. All right, next question. Which headset is not yet released? Two people didn't answer. PlayStation doesn't come out until October. It's the last one to release this year out of the major ones. People are mostly paying attention. B-Slick still up there. But Tektor came in second. What does MLP stand for? I quickly Googled MLP when I was putting answers together for this one. Guess which one came up when I Googled MLP? Yeah, trying to trick people on this one. Read carefully. Yeah, minimum lovable product. Oh, B-Slick still just edging everyone out. All right, 2 questions left, which is not a reason why we went with Google Cardboard. Which is not a reason we went with Google Cardboard. There's supposed to be sound right now. I'm really disappointed there's not any. Oh, so it was revenue. We weren't trying to make money. It was a little bit of a trick because maybe you thought, well, there's a bigger audience and maybe that means more revenue. But the app's actually free. There is like an in-app purchase for a couple extra levels, but no one's really bought that. And we didn't plan on making any money. We did go Google Cardboard because of the game mechanics. There's only one button. Our app was pretty simple. It was actually just mostly around looking at stuff. So that wasn't. Oh no, Be Slick. What happened? Last question. It really might be anyone's game at this point. A Google Cardboard costs about how much? Oh man. $15. Cheapest cardboard, $15. There might be some that are $30 or more. A little bit of a trick question there. People got it. All right, Charlie and Roller are winners. Charlie and Roller? All right, just come see me after the talk, and I'll get your... Yeah, does Be Slick want us? Yes. All right, that was great. I hope that was a good halfway through the talk. Everyone's got sleepy from lunch, you know. Okay, so that's a little intro to VR. Hopefully, got some understanding of the different headsets, Unity, integration to Unity, what you're getting into. So for the next 25 minutes, I want to talk about and get into some code samples of how we integrated Unity with an API in Django. Apologies, I have a feeling some of the code may be a little hard to read because of the aspect ratio, but we'll see. So who has used DRF before? Imagine, okay, so maybe 75% of the room. I'm not going to go too much into DRF. I'm going to just show some of our code. Our DRF implementation is pretty straightforward. We're not doing anything super unique. So why do we even need an API for our game, right? You might be asking yourself that question. There's level packs. There's levels in each level pack, and then each level has a bunch of hidden objects that you need to find. So we wanted to create an API, one, because we want to be able to add new levels and level packs without having to ship a new update to the App Store, because that's a painful process sometimes. If anyone's been through that, they've been trying to make it better. We found through testing that some of our objects were too easy or too hard to find, so we wanted the ability to actually change the object that people were looking for in the level without having to push an update after we did some testing. We wanted to store asset bundles. I'm going to talk about that in a little bit. But we wanted to essentially store a bunch of the pictures and images and sound clips on S3 so that they just get downloaded to the phone. And when you download the app, you're not downloading this hundreds of megabytes app when you first download the app. You download a small app, and it downloads the assets as you play the levels, not all of them at once. For in-app purchases, we want an API so that we can set up identifiers for the level packs that we're setting up in the App Store. So essentially in Google Play, in the Apple App Store, we can create a new in-app purchase for a new level pack, create a whole new level pack with levels and hidden objects all without pushing an update. And a little bit of future-proofing. There could be more complications around actual user accounts or other things in the future, normal reasons why you might need to have a backend to your game. So our models, pretty straightforward. I have left out a bunch of the fields, but I kept in the ones that I felt were most important for just talking through this. So like I was saying, we have level packs. Each level pack has multiple levels. Each level has multiple hidden objects that you're finding in the game. So, and the key here also is that we store these asset bundle names, which again, just keep them in your minds. We're also on our models storing essentially these asset bundles and the links to S3. We also play music, so we also store an audio clip for each level. For the hidden objects, we actually store where the objects are in space in the game. So if you notice, we have fields in there for scale and position. That's so that when we actually load up the level, we put the object in the level based on the data coming from the API. Really, this is our main endpoint from the back end, which is just giving the list of level packs. I don't think I left anything out here. This is really it. Yeah, it returns a list of our level packs. The serializers, again, we just have a bunch of nested serializers. So essentially what this means is when we send down all the level packs, we are sending down all of the levels and all the hidden objects at the same time. It's not a lot of data. We could have done it so you get a list of the level packs, and when you click on a level pack, then you see all the levels, then we make another API request. Didn't really seem necessary. It's really not that much information to send down at once. We do have an API key permission on the endpoints. Really, there's nothing secure or private, though, about this endpoint whatsoever. We did it maybe in the future. Thered be something there. So really, this is pretty transparent, maybe not the most secure, but more or less our endpoint, you need to pass it the correct API key, store that API key in our settings. Maybe that should even be, and then that API key obviously is also stored in Unity on our iPhone and Android builds that are compiled. And then we just configure that one URL with the router. So the Django REST framework, again, try not to give a tutorial, but at least quick. Our models, the key thing is to think about, we got level packs have levels have hidden objects. They all contain the data that we need for the game to kind of dynamically create some of those scenes. So let's talk about how it works with Unity. So when you first open up the app, unlike the proof of concept, we decided when you first open the app up, you're actually greeted with a 2D list of all the levels. Originally, we thought, well, what if you're just in VR the whole time and you pick the level? With Google Cardboard, there's actually even more fatigue. Basically, with smartphone VR, there's even more fatigue by users than if they have the full headset on. Because of the screen door effect, people getting more nauseous, you have to actually hold the cardboard up to your head. It's not strapped. So you look at all the level packs, you look at the levels, you select the level to play, then you go into virtual reality to play the game. From there, you can play a couple levels in a row until we kick you back out and you come back to these screens. So essentially, this first screen makes an API request, gets the list of all the level packs. We show them in a list in Unity. And then there's a little bit of logic on the phone to figure out if you've downloaded the assets for those levels yet, if you need to purchase it, or if you can just play the level pack. And so really, all that happens here is that download button changes to one of those three words. Depending. So I spent a lot of time trying to figure out from Unity how to actually make an API request and get the JSON data and be able to use it easily in our app. Surprisingly, it's not that easy. And what I'm going to show you is going to look really easy. But don't let that fool you. It took weeks of figuring out the right package and how it's supposed to work. So an issue with Unity development, specifically compiling to iPhone and Android, is that there's certain C#.NET libraries in the core library that won't work on Android and iPhone. So there are some built-in libraries that help make networking calls that unfortunately won't actually work on your mobile phone. So that's a huge thing. That wasn't very obvious when starting out with Unity. Once I figured this out, did some reading, I started to look at what alternatives there are, other libraries. I'm like, well, this is Python and Django. I'd be looking at what other people do and looking at their blogs and looking at GitHub and getting some examples. I felt that there's a little bit of a lack of that community feel in Unity development. And I ended up finding this one library after trying a few others that also didn't work. Some of them also depended on Xamarin, which is another kind of cross-platform library. I landed on Best HTTP. The name also threw me off a little bit. I was like, is this really going to be the best library that calls itself Best HTTP? But it was. So maybe they knew. Maybe the person who first made that library was like, I'm going to make the best one. So you actually have to purchase this through the Unity asset store. So at first, my initial reaction was like, there's a store to buy stuff in Unity other people made. This seems like this is different than what I'm used to. Eventually, though, I mean, I think this was maybe There's also a Best HTTP Lite and Pro version. I'm not honestly sure what the differences were, but I think one was $30 and the other was $60, and then you can just use it forever in your game. Comparing that to the already weeks of time I had spent like trying to figure out how to use other libraries or just C# and the .NET libraries itself, definitely worth the time. So I purchased it through the asset store. It kind of like downloads into your app, and then you can use it. And it was great. The only problems I have with it is that the documentation is just a Google Doc. It's not great. Let's just say the documentation is not great. Stuff to be improved there. But so really quick, I mean, you probably already glanced at the code. Once I found Best HTTP, to actually finally make my API request was super straightforward. I give it the URI, essentially the URL to the API endpoint that I'm calling. HTTP request is an object from Best HTTP. It's a class. So you instantiate HTTP request with the URL that your API is going to, and a callback function so that when the API returns, that function is called with your data. Best HTTP seemed to also have a bunch of advanced functionality for WebSockets, obviously making REST calls for all the different verbs, post, get, delete. It seemed really fully featured once I started to dig into it, which is great. So this is pretty straightforward. This is all it ended up taking once finding the right tools to put together. So this other thing, full serializer, I'm not going to go through what this is per se, but the idea is from other experiences on iPhone and Android and in JavaScript, when we're calling our endpoint, I want to take that JSON data on my client, and I want to turn that into actual objects that have that data. And so on a lot of other platforms, there's libraries and ways to kind of automate like deserializing your JSON data into actual objects, whatever programming language you're writing in. So I was looking for something similar in Unity so I could just have some C# objects that actually had a level object, and I had a level pack object that had a bunch of levels. So this is just up here for reference later. This is a class that you put together. I think it's partly in the full serializer documentation. This is just a GitHub repo with some open source software that you can use. Here's actually using it, though. So this is that callback again on request finished that sends back the data once Best HTTP has returned. So if I call that other class I just showed you, the deserialize method, I say, hey, here's the data that Best HTTP got back. Here's my level pack object, which I will show you below here. Just deserialize all that JSON into this object for me, and then give me back a list of level packs. And that's great, and that's more used to what I'm doing in some of our other like thin client platforms that are calling the API. And so like this level pack class that I have below, we also have one for a level and one for hidden objects. All right. So kind of the last part really is how do we make that final scene that's in 3D or virtual reality, depending on how you're playing. So this screenshot is actually what the scene looks like in Unity. So the idea is that we have this very bare bones scene that has some of our UI set up, and from the data that's coming from the API about that specific level, all those green cubes are going to turn into actual objects somewhere in the scene. The level name is going to turn into the actual level name coming from the API. And all those white squares in that menu actually turn into little icons of the objects you're supposed to be finding, as well as their names. So all this data is coming from the API. So originally we had like 6 different scenes with all of this hard-coded in there. And as a programmer, I was like, I feel like I'm repeating myself over and over again right now. And so it made a lot of sense to kind of abstract it out, put it into an API, and have these levels dynamically load. And this took me a while. I talked to another like experienced Unity developer about the problems, and so this is what we ended up with. Specifically, also to note, the photos are just these 360-degree photos that are mapped to the sphere, if you will, around the camera. So in this picture right here, the kind of the white tiled background, all of that gets replaced with a 360-degree photo that was taken inside of the miniature world. The green cubes are actually just invisible. They're placed in the scene over where that object essentially exists on the photosphere. So it's not like we're actually taking a 3D model of an army man and putting it in there. This cube, we actually just changed the shape and the size so that it overlaps on the photosphere with where that object is in the image. So the key here are these asset bundles, which again was this whole concept that seemed very overwhelming at first because I had never dealt with something like this. So the game assets are really large. The photospheres in the game are really large, and if someone had download all of these at one time and all the sound clips and everything, it would they'd have to be on Wi-Fi to download it. They'd be downloading everything. If they only played one level, they have a ton of assets and taking up a ton of space on their phone that they're not even using. So the idea is for them to be able to download assets on demand when they need to. It also gives us the ability to update assets. Maybe we found there was a mistake with one of the photospheres in the level. We could re-upload our asset bundles to S3. The asset bundle manager essentially also has another schema file that has some meta information about what version of this asset bundle it is. So the game can actually detect, hey, there's new asset bundles to be downloaded, and will prompt the user to download the new one and throw out the old one. And these asset bundles can actually contain all different things. They can contain essentially just an image. They could contain a whole scene. So you could actually create a whole new scene, be able to change it kind of on the fly, upload it to your server in this bundled up package, and the game would be able to download it. So a lot of the games, if you've ever played on your phone, are doing things like this. Interestingly, Pokemon Go is made in Unity. Fun fact. So a little bit about the asset bundles before my time is up. So there's a whole asset bundle tutorial. I've got some links in a couple slides. So Unity has all of these example projects on how to use asset bundles and whatnot, but I am just going to show you a little bit of code that might make some of it easier because they show a lot going on there, and it's helpful to just see it actually used. So asset bundle utility, this class is actually a class that's provided by Unity. They give you that you can download through the asset store, but for free from Unity is this whole asset bundle package. Utility is a class in there that helps manage the versioning and all this other stuff that you don't have to write yourself, which makes a lot of sense. This function here is specifically about us loading the photosphere. So in Unity terms, that photosphere is a material. That material is applied to the sphere that is around the camera. So what we're trying to do is we're trying to get from the asset bundle asynchronously the material that we're then going to put onto the sphere in our scene. So at first, we use Asset Bundle Manager to load an asset asynchronously. You give it the asset bundle name and the asset name. So we create one asset bundle for every level pack, and each level knows the names of its assets in that bundle. So it was a better strategy than having a different asset bundle for every level, because if you notice on our first level select screen, we prompt you to download a whole level pack. So it made more sense for the whole pack to be an asset bundle, and it contains the assets for each level. Those levels from our API know what the names are of those assets in the bundle. So we load this asynchronously. Once it comes back, this I enumerator in front of the name of the method essentially denotes that this function can be run asynchronously as a coroutine in Unity. So when it returns, we get a material from the request to the asset bundle manager, and then we can just put that material onto our mesh renderer, which is, you get into Unity, mesh renderer is just the thing that's attached to the sphere that actually renders the picture. So in our actual code, once I created this function inside of Unity's asset bundle utility, I would then just call off, I would start a new coroutine, which means basically call this method asynchronously. Because in games, often you don't want to block the game, because the user will just get this black screen. Especially if you're in virtual reality, you would cause your user to get sick immediately. If all of a sudden they're in some virtual world, you pause the game and it shows black because you're loading assets in. You just need to think a lot about probably preloading assets so that they have a continuous, smooth experience and you're not jarring them with like a loading screen in virtual reality or flashing from black back to like a new world. Things like that you need to be careful of. So here we just give it the asset bundle name of the level pack. We give it the name of the photosphere asset itself. That might be like Dino War photosphere. And then the actual renderer that we're using in our current scene that we're loading. So a bunch of resources that you can use. So specifically, I learned a bunch of my Unity VR stuff by watching this Udemy Unity VR tutorial. It is really great. It seems even since I've watched it, they've added a ton of content. And it looks like they've added content also for Rift and Gear VR as well, on top of the cardboard stuff that was in there. There is a specific GitHub repo I looked at about how to actually map photospheres to a 360-degree world in Google Cardboard. That was super helpful. A link to best HTTP, full serializer. I would recommend if you're getting involved that you just open up Google Cardboard's example Unity project and just click around and explore. That's how I figured out a lot of what was going on. The Ricoh Theta S is the camera that we used. If you probably wait even longer, there'll be cheaper ones that are coming out. And then the Unity Cardboard tutorial. Unity's got a bunch of tutorials themselves and videos as well, video walkthroughs if you like to learn that way. And then the Asset Bundle Manager. And that's it. So these slides are up at that URL. If you want to go back here, all of those are actual links that you can click on to go to there. That's it. I got 5 minutes for questions.
Pretty awesome what you did there. Will this scale well when you have, like, say, 1 million users?
Right now, yeah, because really the API interaction is just when someone opens up the app. There's no ongoing while you're playing the game. It would be concerning if, for example, we were like saving scores or achievements or whatnot. But still, it's not super complicated. You would just need to make sure that you were scaling your servers well enough to handle the traffic.
Hey, why did you choose to query for all of the level data from a server rather than just bundle that data into an object in the asset bundle?
So if we went that route, that means when the app opens, before anything happens, the app needs to have a hard-coded URL of where to go to get the asset bundle, if that was to happen. And then it would need to check the version of that asset bundle and download it and then figure out the data in there. Our idea was the API would also grow into more than just having the information for the scene. But it's a possibility. It's a way you could do it. Cool. Thanks.